Hi, welcome to the Olympiad geometry. Let's continue our study. So today we're going to talk something really fun. Some audience asked me the question that whether the AI is a very powerful tool for the Olympiad geometry. My answer was I don't know, because I never used it for the solving the problems before. And when I prepare for the Chinese version of the property of centroid, I found this interesting property, and I want to try it using the AI tools to see if AI tools can solve this problem. And before that, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. So let's see the problem first. It's a property of the centroid. G is a point inside triangle ABC. Extension of AG, BG, CG. Actually, I already draw the figure, so let's. Okay. G is a point inside the triangle ABC. Extension of AG, BG, CG intersect BC, AC, AB on DEF respectively. Prove that G is centroid if and only if the area of triangle AFG, right, this is F, the area of triangle AFG and triangle BDG and triangle CEG are equal. So first, let's try to solve this problem. It's obvious that if G is a centroid, that these three areas are equal, but it's not that easy once you try to show that these three areas are equal, and you want to show that G is a centroid. That's not that easy. Let me have a pen here. So I would show you how to solve this problem, or how to solve this property when I talk about the centroid. But let's just have a review for preview for this one first. So assume that we can set the area of triangle AFG. I really need a pen. Where's my pen? Okay. Oh, I have to keep this here. Okay, that's fine. So the area of triangle AFG to be 1, and the area of triangle BDG to be 1, and the area of triangle CEG to be 1. That's fine, right? Because we already know they're equal. We can just set as a unit area. And then we assume that the area of triangle BFG is X, and the area of triangle CDG to be Y, and the area of triangle AEG to be Z. That's fine, right? So if we use the Sylvers theorem, we got AF to FB times BD to DC times CE to EA equals to 1, which means 1 to X times 1 to Y times 1 to Z equals to 1, right? But this can basically tell us nothing. So let's try to figure out something else. Look at the ratio of BD to DC. BD to DC equals to, BD to DC. Let's just look at AF to FB first. AF to FB, right, that equals to 1 to X. And it also equals to 1 plus Z to 1 plus y, right? Because 1 to x is the area ratio of triangle AFG and triangle BFG. And we already know that AF to FB equals to AGC to BGC, right? And the area of AGC is 1 plus z, and the area of BGC is 1 plus y. Similarly, we can have 1 to y equals 2. See here, 1 to y equals 2, 1 plus x, 2, 1 plus z, right? And also we have CE to EA, which is 1 to z equals 2, CE to EA, right? CE to EA, that's 1 to z and equals to 1 plus y, 2, 1 plus x. Now we think about the relationship of x, y, z. It has only 3 cases. It has only 4 cases, right? So first one is that x is larger than y and larger than z, right? Because it's kind of symmetrical, so it doesn't matter in another order. But let's just assume that x can be the largest. So x larger than y larger than z. That's the first relation. And the second one is x equals to y larger than z. And the third one would be x larger than y equal to z, right? And the fourth one would be x equals to y equals to z. Okay. For the case that x equals to y equals to z, obviously G would be the centroid, so that's fine. But for the case x larger than y equals to z, because y equals to z, that means x equals to 1, right? And because x equals to 1 and y equals to z, so y equals to z equals to 1, which means x actually equals to y equals to z, which means this is impossible. And similarly, this is impossible. What about x larger than y larger than z? X larger than y larger than z. That means 1 over z would be the largest in 1 over x, 1 over y, and 1 over z, right? So 1 over z would be larger than 1 over y and larger than 1 over x, right? But the problem is that because x is larger than y, so we already know that 1 over z equals to 1 plus y to 1 plus x, and this is less than 1, right? What about 1 over y? 1 over y equals to 1 plus x to 1 plus z, and this one is larger than 1. So we have 1 over z is smaller than 1 and 1 over y is larger than 1, and we believe that 1 over z should be larger than 1 over y. That's impossible, which means this case is impossible. That means x can only be equal to y. X can only equals to y equals to z, right? Can only be one out of these 3. So in that case, we just prove that G is the centroid of triangle ABC. Okay, that's the solution from me. And now let's look at the AI. I just input the problem, and let's see what the AI said. I don't want to read like so lengthy ones, but just to look at the step 2. If the 3 areas are equal, then G is a centroid, and the ChatGPT is saying that conversely, suppose that these three areas are equal, then the total area of a triangle ABC is divided into 6 smaller triangles. That's fine. And since the area of these three triangles are equal, this suggests that medians divides the triangle into equal area region. I mean, how can you get that? You can't. You can't just think that, right? And this definitely cannot be a proof of math problem. So ChatGPT is useless, at least on this problem. Let's look at Julius AI, right? I input the problem here, and let's just see the proof. Let's see the reverse direction, that if SA equals to SB equals to SC, then G is a centroid, right? Okay, let's see. It seems that equal area implications that assume all these three areas are equal. This means that the height from point G to the side BC, CA, and AB must be such that the ratios of the bases, the segments AF, BD, and CE. Let's look at the figure. Right, so let's look at the figure. I don't want to. Okay. AF, BD, CE. That's fine. Using area formula, the area of triangle AFG can be expressed as SA equals to half AF times HA, okay, where HA is the height from G to BC. No way. Similarly, we can express SB and SC. No, that can't be correct, right? That's definitely wrong. And final statement, no. So Julius AI is also useless in this problem. Let's see another one that recently is very popular called DeepSeek. And part 1, if G is centroid, okay, I don't want to see that. What? Wow. It's very lengthy to just prove that, right? Yeah, I don't want to read this one. It's too lengthy. Basically useless. And that's a conclusion for part 1. The part 2. If the areas of triangle AFG, BDG, and CEG are equal, then G is a centroid. Step 1, assume areas are equal. Okay? We already know that, right? We don't need to assume, but let's see. Assume that the areas of these triangles are equal. Let's denote the common area as K. What is common area? There's no common area. Okay, it's saying just okay. All of these areas are equals to K. That's fine. And express areas in terms of ordinates. Using the ordinates from part 1, we have, in part 1 definitely the DeepSeek put some ordinates here, but that's fine. Then area of AFG equals to this one equals to K, and area of BDG equals to this one equals to K, area of CEG maybe continue, equals to this one equals to K. Okay, that's fine. I'm not sure if this is correct, but let's just say it's correct. Related to the centroid property, we know that G is a centroid, the areas are equal. Now we need to show that the converse is true. If the area are equal, then G must be the centroid. Okay. It keeps supposing that G is centroid and then just show us what we already know. See here, suppose G is not the centroid, suppose G is centroid. These are not all 2 to 1. This would affect this, making them unequal unless G is specific. No, you cannot prove a math problem by saying that, right? You cannot just say, oh, the ratio of AG to GD, BG to GE, CG to GF are not 2 to 1, then it would affect the area of these three and then making them are unequal. No, that's not true. You cannot do that. So that's the three most popular AI I can find. But as you can tell, they all use this in solving at least for this problem. I think the issue here is that these AI tools are not designed to solve a geometry problem, and I actually use like ChatGPT very often for programming, but not solving the geometry problem. I think I would have a conclusion here is that at this moment, I think there are abundant problems that cannot be solved by the AI. Okay, so I would not recommend the audience to use AI tool for learning geometry. Besides, let's just assume that in the near future, maybe there is one AI tool that can solve most of the Olympiad geometry problems. But would that be a good thing for the audience? Would that be a good thing for the learners of the Olympiad geometry or Olympiad math? I don't think so. Because the key point of learning Olympiad math is to focus, right? Is to practice. Through solving the problem, you can improve your skill, and also you can improve the way that you do analysis and you think of one thing in different perspective. I think that's a key point of learning Olympiad math, and that's a key factor you would develop in the future in your research or maybe in your work, and that cannot be replaced by an AI tool. So I would appreciate my audience to suggest me to do this video. I guess we just prove that no, we don't want AI tools. We want to use our own brain to solve a problem, right? We have a lot of fun when we use it, rather than just reading these AI tools giving nonsense. Okay, that's it. That's this video. I hope you like this video. I hope you enjoy this problem. See you in next one. Thank you.